Angles formed by parallel lines and transversals. Our objective is to prove and use theorems about angles formed by parallel lines and a transversal. Who uses this? Piano makers use parallel strings for the higher notes. The longer strings used to produce the lower notes can be viewed as transversals. Let's look at the corresponding angles postulate. If two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. So if P and Q are parallel, we know that angle 1 and 3 are congruent, 2 and 4 are congruent, 5 and 7 are congruent, and 6 and 8 are congruent. Let's look at a few examples of this. Find each angle measure. Okay, so if we're looking at, we want to find the measure of angle A, B, C. Since this 80 degrees and our x degrees are corresponding angles, and we have a transversal that's cutting through two parallel lines, we know that they have to be congruent. So the measure of ABC is going to be 80 degrees. Let's look at the measure of angle DEF. This one's a little bit trickier because it involves some algebra. However, the same philosophy still exists. We know that this angle here and this one here must be congruent. So let's set them equal to each other. And now we can solve for x. So x minus 45 equals 30. Add 45 to both sides, and x equals 75. We are not done yet. We wanted to know the measure of angle DEF. So plug 75 in for x, or substitute that in, and we have 75 plus 30, which gives us 105. Let's look at some theorems. The parallel lines and angle pairs. Okay, we have the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Same with the alternate exterior angles theorem. If two pairs of lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. So angle 1 and 3 are congruent, 2 and 4 are congruent, 5 and 7, 6 and 8. So corresponding angles, alternate interior and alternate exterior angles are all congruent if the lines are parallel. Same side interior angles theorem states if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. So that would be when you add 2 and 3 together, you're going to get 180 degrees, just like if you were to add 1 and 4 together. Let's look at a proof. We're given that line L is parallel to line M, and we want to prove that angle 2 is congruent to angle 3. For this one, we're going to practice using a flowchart. Okay, so we start with our given. So we have our L is parallel to M, and that would be given. All right, well, based on that given, we know that we can use 1 and 3. So angle 1 and 3 are congruent because of the corresponding angles postulate. Remember, a postulate is something you can use without proof, whereas a theorem you have to prove. So we have the corresponding angles postulate. All right, well, we need another piece of information before we can suddenly state that 2 and 3 are congruent. We can use that angle 1 and 2 are congruent because they're vertical angles. So angle 1 is congruent to angle 2 by the vertical angles theorem. And then we can state our final piece, where angle 2 is congruent to angle 3. Because we've got angle 1 is equal to angle 3, angle 1 is congruent to angle 2, so therefore angle 3 and angle 2 must be congruent because of the transitive property of congruence. Let's put these theorems to work. Alright, so we're going to find angle measures. We want to find the measure of angle EDF. So EDF is this angle right here. And we can use alternate exterior angles to help us out, since we know that line BC and ED are in fact parallel. So therefore, measure of angle EDF must also be 125. Alright, now we have the measure of TUS. So it's asking about this angle right here. Well, we know that same side interior angles must be supplementary if these two lines are parallel, which they are. So we can set them equal to 180 degrees. So 13x and 23x gives us 36x. Divide both sides by 36. We have x equals 5. We're not done yet. We still need to plug our x value in. So we're going to substitute 5 in for x and get 115. Let's look at our music application. The treble strings of a piano are parallel. Viewed from above, the bass strings form transversals to the treble strings. So find x and y in the diagram. So we want to find the value of x and y in this diagram. Alright, well, we know that 25x plus 5y needs to equal 125. So we have 25x plus 5y needs to equal 125. And we also know that 25x plus 4y needs to equal 120 degrees because of the corresponding angles postulate. So we have 25x plus 4y equals 120. Since we have two variables that we're trying to solve for, we're going to need to use this like a system of equations. So we're going to subtract our bottom equation here from our top because we want to eliminate one of the variables. And if we subtract 25x minus 25x, it eliminates that for now. So then we have 5y minus 4y leaves us with a singular y. And then 125 minus 120 gives us 5. Well, we still haven't figured out what x is. To figure out what x is, we're just going to simply plug our value of y back in. So we can go 25x plus 5, and then substitute our 5 in for y, equals 125. And now we can simplify. So we have 25x plus 25 equals 125. Subtract 25 from both sides, so we have 25x equals 100. And then we can divide by 25 on both sides, leaving us with x equals 4. So we have y is 5 and x equals 4. And that concludes our lesson on angles formed by parallel lines and transversals.